Hello, everyone. In this talk, I'm going to discuss some of our initial work on building what we call a privacy first data management system. Let me start with a quick summary. Over the last few years, there has been a strong movement towards more ethical and transparent use of personal data, with privacy being one of the most concrete and visible issues. This has led to a major upheaval in many industries, especially ad tech and marketing, but many others as well. And organizations all over are scrambling to come up with short term and long term solutions to address this challenge. I believe that the data management community has a major role to play in this, going far beyond the work so far, which has largely focused on issues like encrypted computations or differential privacy. I believe we really need to start thinking about how data management systems are built and designed and architected with privacy in mind from the ground up. So, in this talk, I will discuss some initial work on re architecting a typical relational database management system to solve just some of the privacy related issues. As I'll discuss, even within this narrow scope, there are many new and hard research challenges that need to be addressed. And to address the broader challenges in privacy aware data management, it will take a much more concerted effort from the entire community. With that, let me dive into some of the details. The importance of privacy today, I don't really need to belabor. We have seen many high profile data breaches. People are starting to realize how much their data is worth and how it is being shared with many, many entities in today's world. Consumers are increasingly starting to care about ethical practices of the companies that they do business with, and of course, the regulations. 5 years ago, HIPAA was probably the only one you cared about, and that also only if you handled health data. Today, most people are aware of GDPR, LGPD, CCPA, CPRA, and many other acronyms like this. I can't really do justice to the privacy regulations in the limited time that we have here, but I did want to highlight some of the principles that show up in most regulations. These include things like providing customers with enough transparency and notice and allow them to make choices, providing them with rights to their data, explanations of decisions that are being made about them, due diligence of partners with whom data is being shared, accounting of data transfers both internally and externally, issues around fairness, bias, ethics, principles such as data minimization, limiting the amount of data that you collect, purpose limitation, using the data only for the purposes for which it was collected, access minimization, and of course, privacy by design sort of encompasses many of these and is explicitly part of many privacy regulations. The main thing I want to note here is that many of these are fundamentally data management or data usage problems. They are about how data is collected, what data is collected, where is it being used, how it flows through different data processing pipelines, and so on. However, because of the way we have been doing things for such a long time, because of the way how data is being collected, processed, analyzed over the years, this is really challenging. Fundamentally, the data management ecosystem and all the tools that we have built over the last 4 or 5 decades are designed to reduce the friction in making it easy to process and analyze the data. Many things like auditing, tracking of provenance, access control are often an afterthought to the main goal of essentially enabling more and more data analysis. Some of the other things that have come up in the last couple of decades that make things even more complicated are widespread use of APIs to share data with partners and users, and just in general, a rise in the use of specialized third parties. And also the fact that personal data today encompasses much more than what we might have considered 20 years ago. So this brings us to our point that we made earlier, is that we really need to start re-architecting data management systems to support privacy controls from the ground up. So moving on to Sypse and what we've been working on so far. Sypse targets three of the privacy goals that we have discussed so far. One is trying to reduce impact of breaches. Second is making it easy to comply with deletion requests, or what are often called right to be forgotten requests. And then reduce the need to access personal data by employees who don't need access to that data. The initial work has been done in the context of a single site relational database, but it generalizes naturally to distributed multi-party settings and also to relational data formats like Parquet rather than relational databases, and to hierarchical data formats. But I do want to stress that this is very preliminary work and there are many unsolved and hard research problems that need to be worked on to make this vision a reality. Um, Sypse is based on three ideas. First is pseudonymization. Pseudonymization has been around for a very long time as a way to dissociate personal data from identifying information. It has been used for data publishing, and increasingly it is being used sort of to embody privacy by design principles in systems. The basic idea here is to replace personal identifiers with randomly generated pseudonyms. As an example, we'll use the typical TPCH kind of a database. So here we see a customer table with some personal information and an orders table which has sort of less directly related personal information. The way we can separate the order information from the customer information is by essentially replacing the customer ID in the second table with randomly generated IDs, and then having an explicit mapping table that allows us to connect the two pieces of information. Ideally, this kind of dissociation is done at multiple different places within the database, as we'll discuss later in the talk. Um, a key thing to note here is that pseudonymized data is not the same as anonymized data. It is possible to re-identify individuals in many cases fairly easily. And because of that, pseudonymized data is not really considered sort of non-personal data. It is still personal. It still needs to be treated very carefully, and you can't just make it available to anyone without restrictions. But there is a less of a risk in case of a breach, right? The entity who has acquired the pseudonymized information does need the mapping tables in order to be able to connect that information with the individuals whose information it is. The second principle is that of data partitioning. And the simple idea here is that we take the database and break it into pieces so that any one piece has low value by itself, but we still are able to do whatever queries or analysis that we want across those databases. This will help us reduce the impact of a breach. Of course, the main drawback here is that this has significant performance implications. Any queries that span multiple partitions are essentially going to become distributed queries or distributed transactions, and performance implications must be dealt with. The third idea behind Sypse is to use synthetic data to provide differentiated but uniform access to the data. But the key design goal that we have here is that everyone sees the same schema and can run the same queries. And this is designed to reduce friction in deploying a system like this. So Sypse is designed as a drop-in replacement for a relational database. In our preliminary work, in our prototype, it supports two partitions of data and two access levels. And we envision doing the decisions of how to partition and pseudonymize the data in an automated way. Even within this limited context, there are actually many different ways to employ pseudonymization and partitioning to achieve the goals that we have discussed so far. In the paper, we discussed three such strategies. The first strategy is a simple one that essentially introduces pseudonymization at various different points in the database and maintains the mapping tables in the PII partition along with any PII information about the customers. Um, the second and the third strategies use encryption in different ways to achieve essentially the same goals but with different trade offs. And we have also presented some preliminary experimental results that discuss the trade offs between these strategies and essentially validate our main assertion that such systems can be built at a reasonable performance while achieving significantly higher privacy guarantees than we had available before. There are many challenges, some of which we are working on in our ongoing work. Understanding what progress we are making towards privacy goals is very difficult. Privacy schemes tend to be binary in nature. In the real world, this is really more of a spectrum. Um, Companies are trying to make decisions about where in the spectrum they are comfortable with, and we are not aware of any sort of theory that allows us to understand that spectrum in the context of such a data management system. We need to develop new techniques to partition the tables, um, schemes to analyze the schema in an automated way so that decisions about how to partition and break up the connections between the data are made in at least a semi-automated fashion. And finally, the performance. Um, there is the query and transaction costs are much higher in any such system, and those need to be dealt with before such a system can be used in practice. So with that, I'm going to end my presentation and happy to take questions on this. Thank you.